Hello students, let us discuss about the CBSE Chemistry paper. As you know, in the CBSE Chemistry paper of class 12th, the syllabus is there are 10 chapters in chemistry, and out of these 10 chapters we have 3 chapters from the physical chemistry, namely solutions, electrochemistry, chemical kinetics, and 2 chapters from the inorganic chemistry, D and F block of the periodic table and coordination compounds. And we have 5 chapters from the organic chemistry, namely haloalkanes and haloarenes, alcohols, phenols and ethers, aldehyde ketones and carboxylic acids, amines and biomolecules. And if you see the weightage, each chapter on an average has a weightage of 7 marks. So all chapters are equally important. And if you look at the structure of the question paper, there will be 5 sections in the question paper. Section A, which consists of 18 questions, are MCQ type, including assertion reason. No negative marking, so you must attempt each and every question in this section. There may be internal choice, but there is no overall choice in the question paper. Then we have a section B, which are short answer type questions, 2 marks each, and in this section there will be 7 questions. In section C, also a short answer type question, and this section contains 5 questions of 3 marks each. Then we have a section D, where you have 2 questions, case-based study questions, where the paragraph will be given followed by 3 or 4 questions, where you have to use some knowledge from the present class 12th chemistry, and some knowledge will be given in the question itself. Some information will be given in the question itself. So use that information along with your own concepts and then you answer the questions. And in the last section, that is section E, there will be 3 questions, 5 marks each. There may be internal choice again, but no oral choice in the question paper. So overall, total 35 questions will be there. The next, how to attempt the question paper. So you have to follow certain tips. For example, in physical chemistry, whenever you have to solve the numerical, you always write the formula first, then put the values, then calculate the value, numerical value, and finally you write the units along with the value. Sometimes we give a question where we give maximum weightage to the units. So if you are not writing the units, sometimes you may get 0. For example, one question from the electrochemistry. Question was to find the cell constant. Find cell constant of a 0.02 molar NaCl solution which has a conductivity of 1.20 into 10 raised to power minus 3 Siemens centimeter inverse, and the resistance of this solution, resistance of this 0.02 molar solution given is 200 ohms. Suppose these are the values given. Now the question is find the cell constant. So you write the formula first, that cell constant is equal to, it's the conductivity is the kappa into resistance. Now you multiply the conductivity 1.20 into 10 to the power minus 3 Siemens centimeter inverse into 200 ohms. This is a symbol for ohms. So whatever the value comes, you write the value, then write the units centimeter inverse. So units are very important whenever you are solving the numerical. So the answer is 0.240 centimeter inverse. Another point, very important point, whenever you have to plot a graph, like in solutions, you have to show the variation of vapor pressure against mole fraction, or you have to show the depression freezing point, elevation boiling point, always plot a graph with a pencil, and the graph should be well labeled graph. For example, if you want to show positive deviation from Rod's law graphically, then the graph will be like this. It should be a well labeled diagram. Like this is the vapor pressure on the y-axis and the mole fraction of the component B on the x-axis, which varies from 0 to 1, and this is the vapor pressure of one of the component, and this is the vapor pressure of the second component, and this is the vapor pressure of solution. Assuming this is an ideal solution. Now since the system is showing a positive deviation, you have to show the graph like this. So this dotted line represents the positive deviation. So it should be a label diagram. When you are writing the answer in physical chemistry, you have to take care of these things. Graph should be a labeled graph, and whenever you are solving the numerical, you write the formula, put the values, then calculate the numerical value and the units. Like in the D and F block, there are number of equations are there, number of reasoning questions are there. Whenever you write reasoning, you highlight the value points. And whenever you write a diagram, you show the lone pair if any lone pair present, draw the shape, write the shape, name of the shape, bond angle. So all these things you have to take care of. And in the coordination compounds, you have to write the geometry, you have to write the magnetic properties, you have the correct name of the coordination compound. For example, this. Now this is a complex of iron given to you, FeCl2, En whole twice, and the whole complex is carrying a positive charge. Now suppose the first question is write the IUPAC name, then you just write the IUPAC name. It's a dichlorido bis ethane 1,2 diamine, ethane 1,2 diamine, then we write iron and then followed by its oxidation state. So if the question is there, write IUPAC name, write IUPAC name only. Then the second question is, what is the geometry of this complex? Now if you look at the complex has a coordination number of 6, and all 6 coordinate complexes have an octahedral geometry, so you don't have to work out, you simply write it is octahedral. Then the question is, what are the hybrid orbitals used by iron? You write what are the hybrid orbitals. There is no need to draw the box diagram. You simply write D2sp3. So the hybridization of iron in this complex is D2sp3. So iron has used 6 hybrid orbitals in forming the complex with chlorine and the ethane 1,2 diamine. The next question comes, is this complex paramagnetic? Is this complex paramagnetic? You have to write yes or no. So the complex is paramagnetic, and since iron 3 plus has a configuration of argon 3d5. Now since this number is an odd number, you cannot pair up all these 5 electrons, 1 electron remain unpaired. So that's why the complex show paramagnetism. The next question comes, any geometrical isomerism possible? Yes. So yes, the complex will show geometrical isomerism. Geometrical isomerism. The question was, will this complex show geometrical isomerism? Yes. You don't have to draw the geometrical isomers. If the question comes, draw the geometrical isomers, then you draw the complex geometrical isomers like this. Now this is called a cis isomer, and En is a didental ligand, and the complex carries a charge of +1. So don't forget to put a plus charge on the complex. Now this is cis isomer, you have to label the isomer, and this is called trans isomer, in which the 2 chlorine atoms are on the opposite side of the plane. Again, showing the positive charge in the complex is very, very important. So this is the way you have to answer the questions in coordination compounds. Now next, in organic chemistry, we have a different types of questions. Like we can give a question, how to distinguish the pair of organic compounds. So whenever you have to distinguish the pair of organic compounds, you prefer the answer in tabular form. Write the name of the test, name of the reagent used, then write your observation. For example, if you have to distinguish between 2-methyl propanol and 2-methyl propane 2-ol. So this is one of the question given, and you have to distinguish this pair of organic compound, and you distinguish the pair of organic compounds by giving some chemical test. So you draw the structure of these two compounds. This is 2-methyl propanol, 2-methyl propanol, and this is 2-methyl propane 2-ol. Then you find the degree of the alcohols given. Now this is a 3-degree alcohol, this is 1-degree alcohol, and whenever you have a difference in the degree of alcohol, you always prefer Lucas test. So here you write the test, the name of the test is the Lucas test. Then you write the reagent used. What is the Lucas reagent? So it's a hydrochloric acid, anhydrous ZnCl2. Then you write the observation. Since the first alcohol is a primary alcohol, it does not react with Lucas reagent, so it does not react. Or it does not give any cloudiness. But second alcohol is a 3-degree alcohol, so it gives the cloudiness, turbidity, milkiness, you write anything. So it gives cloudiness instantly. So this way the answer is very clear to the examiner to decide 1 or 0. So always prefer these type of questions in a tabular form. Then the second type of questions are how to perform the conversions. So whenever the question comes on organic conversions, you write the reagents, reaction conditions on the arrow itself, and write the steps in continuation. No need to write any side product, no need to balance any step. For example, and also try to complete the conversion in minimum number of steps. For example, if you have a conversion like convert a propene into a 1-iodopropane. First of all, you write the structure of the starting compound and structure of the final product. Now this is the propene, and you have to convert this propene into 1-iodopropane. So if you compare these two, it means you have to add HI. But we cannot add HI to the number 1 carbon of this propene. The only group which we can add, the only halogen which we can add to this number 1 carbon of the propene is the bromine. So we have no other option except to add bromine. So first step is we are adding bromine using HBr in the presence of organic peroxide. So either you write organic peroxide or simply write peroxide, and if you know the name of any organic peroxide, you write. For example, benzoyl peroxide. But writing peroxide is very, very important. So the reaction follows anti-Markovnikov rule and it gives 1 bromopropane. Now you decide how to replace bromine by iodine. So we use a Finkelstein reaction using NaI in the presence of dry acetone. So in this case, we are able to complete the conversion in 2 steps. No need to write any side product and write all conditions, reagents on the arrow. Now one more question is convert ethanol into, this is from the aldehyde, ketones and carboxylic acid, ethanol into 2-hydroxypropanoic acid. 2-hydroxypropanoic acid. So again you write the structures of these two compounds first. Now this is ethanol and it contains a carbon-oxygen double bond, unsaturated. So undergo addition reaction, nucleophilic addition. Now this is structure of 2-hydroxypropanoic acid. Now it contains 1 carbon more than the parent ethanol, and carbon can be increased by using cyanide. So in this case, the first step is using the cyanide, hydrogen cyanide in basic medium, and it gives a cyanohydrin. So this is step number 1, adding hydrogen cyanide across the carbonyl group, and then we hydrolyze the cyanide using H+ ion, you write, you write water oblique H plus ion, or you can write dilute sulfuric acid, it's one and the same thing. So this is 2-hydroxypropanoic acid. So try to complete the conversion in minimum number of steps. Now the next type of questions are, write the structures of the compound of a given chemical equation, given chemical reaction. For example, the question is, write the structure and IUPAC name of compound A in the following reaction. And this is a reaction given. It's a CH3CHO on reaction with dilute NaOH. It gives a compound A. Now you don't have to write the reaction again. The question is, write the structure and IUPAC name. Now this is a question based on aldol condensation. It's a name reaction. So you write in your rough work what is the structure of A first. Now this is ethanol and it's a condensation. It's a self-aldol condensation. You have to take two molecules of the same aldehyde. So one aldehyde you write in this form in your rough work, which is called substrate, and you write the second molecule as H plus ion CH2 minus CHO, and always split the alpha carbon as H positive and the carbon negative. This is called enolate. Now aldehyde ketone reactions are nucleophilic additions, so the addition takes place across the carbonyl group and the product A is obtained. So all this we are doing in the rough work. So this is the structure of the compound A. So when you write your answer, you write this is structure of A, CH3, CHOH, CH2, CHO. Then you write this is the IUPAC name of A, 3-hydroxy butanol. So you write the answer in this form, and this you can do in your rough work. But when you're writing the final answer, you write this is the structure, this is the IUPAC name. And you will get 1 mark for writing both correct. If one part is correct, second is wrong, nowadays they give 0. So both these parts should be correct, structure as well as the IUPAC name. So in organic chemistry, writing the correct reaction conditions is very, very important. I'll take one more example. Now suppose the question given is this: what is the product form in this reaction? It's a chlorobenzene reacts with dilute NaOH. Now in this case, the many students they write the phenol is one of the product. Many students write no, it's a para-hydroxy, substitution takes place at the para position. Some students write substitution takes place at ortho position. Now in this case, since the chlorine is bonded directly to benzene, this chlorine cannot be replaced because this carbon chlorine bond has a partial double bond character. So we need drastic conditions. So if you are using just dilute NaOH, then nothing happens, no product. So you have to use the drastic conditions. So we use these drastic conditions using dilute NaOH, 623 Kelvin, 300 atmospheric pressure. Now again the question comes, what is the product form? In this case also, majority of the students they write phenol. No. In this case, once the phenol is formed, now since phenol is acidic in nature, this phenol immediately gets neutralized by the NaOH and forms a salt called sodium phenoxide. So the product of this reaction is sodium phenoxide and not phenol. So you have to be very, very careful. So read the conditions very carefully. So sodium phenoxide. Now if I change my conditions like this, so I am writing dilute NaOH, 623 Kelvin, 300 atmospheric pressure, and then I am writing dilute HCl. So in this case, the final product will be phenol. So once the sodium phenoxide is formed, that sodium phenoxide gets acidified by dilute HCl and gives phenol as the final product. So all these three reactions are different. Although parent compound was same chlorobenzene, so with the dilute NaOH, nothing happens, no product. If you are using dilute NaOH, 623 Kelvin, 300 atmospheric pressure, yes, substitution will take place, but you won't get phenol. The product will be sodium phenoxide. And the sodium phenoxide gives phenol only when you acidify it. So you read the conditions very, very carefully. The next type of questions are the questions based on the name reactions. Like question comes, explain Hoffman bromamide reaction, explain Cannizzaro reaction, explain Finkelstein. We can give any name reaction. So how much you have to write in the name reaction? Suppose you are given this. Explain Hoffman bromamide reaction. Or write a short note on Hoffman bromide reaction or illustrate Hoffman bromide reaction. So how much you have to write in this? Now first you write Hoffman bromide reaction in words, that this is a method to prepare. This is a method to prepare amines from amides using bromine and alkali. Alkali can be KOH, alkali can be NaOH. And the amine obtained contains one carbon less than the parent amide. Then you write a general reaction like this is amide RCONH2. You write on the arrow bromine and alkali, KOH, NaOH. Then you write the final main organic product RNH2, and these are the side products KBr, K2CO3 and the water. And there is no need to balance the organic reaction. And then you write one simple example by taking R as methyl. So don't take any hi-fi example, take the simplest amide. So in reaction with bromine and KOH, it forms CH3NH2 and then you write the side products. So in organic name reaction, the side products are not important as they are important in the inorganic reactions. So this much you have to write whenever the question comes, explain this name reaction or explain this name reaction. Next question based on the mechanism. Whenever the question is based on the mechanism, you have to use the curved arrow notations and you have to show the correct position of the positive and negative charges. For example, if the question comes, explain the acetylation of primary amine. Acetylation of primary amine. Now it can be any primary amine. We can specify the primary amine also like methylamine, ethylamine. Now this is acetylation. Now this is acetyl chloride, which we generally use for acetylation. It can be acetic anhydride also. Acetylation is very specific. When we say acetylation, it means you have to replace the hydrogen by COCH3 group. This is very specific. Now this is a primary amine in which the nitrogen is carrying a lone pair. So this nitrogen is electron rich. It can be any primary amine, and since this carbon oxygen bond is polar, so the electron pair will shift towards oxygen and the nitrogen attacks at the carbon. So these are called the curved arrow notations. As a result, the oxygen acquires a negative charge and the nitrogen acquires a positive charge. So this is the first step in the acetylation of primary amines. The next step is this negative charge of oxygen, the electron pair from this oxygen shift back to this side. So again this carbon oxygen bond becomes a double bond, results in the loss of chlorine as Cl negative or CH3COO as CH3COO negative. And this electron pair, the NH electron pair, will shift back to nitrogen, and the hydrogen is lost as H plus ion, which combines with Cl negative to give HCl as a side product, or it gives acetic acid as a side product. So the main organic product is CH3, C double bond O, N, R, and this is H. So this is the mechanism using the curved arrow notations for the acetylation of primary amines. So these are the simple things you have to follow when you are writing your answer. Careful about these curved arrow notations, about the plus and minus charge, and whenever you write the conditions, write the proper conditions, and write answer in a simple, in a stepwise manner. So you have to follow certain tips to score the maximum in CBSE chemistry. Another thing is when you revise from your class notes at this point. Don't study from any other new book. And especially in the organic chemistry, the question comes from the NCERT, especially the in-text questions. So you must solve each and every in-text question given in the NCERT. Another thing is when you revise these 10 chapters, you keep changing the sequence of the chapters. For example, don't revise all 5 chapters of organic at a stretch because it's a heavy dose. So once you do haloalkane and haloarenes, you do one simple chapter from the physical, like chemical kinetics. Then you have alcohol phenol ethers. You switch to, again, in our physical chemistry, do some electrochemistry chapter. Then if you are doing D block and F block, then do the coordination also, because these 2 chapters are interconnected. Now aldehyde ketone and carboxylic acid is a heavy dose, and when you are revising aldehyde ketones and carboxylic acid, you take a small chapter, biomolecule. So this way you keep changing the sequence of chapters when you revise. Keep yourself fresh, motivated, and go through the NCERT as much as you can. And if you want to see more question papers, sample papers, click the link given below.